So this is another video on percent yield. I'm just going to show you two examples that will look similar to some of what you're going to practice on the worksheet and see on the assessment. So this example, so you'll always have a chemical reaction, and then they're going to have to tell you how much reactants that you have. They might give you both, like the next example, and then you have to determine the limiting reactant first. In this question, I'm saying that I have 75 grams of this carbon monoxide, and then reacts with excess hydrogen, which means this is my excess reactant, which means this is my limiting. So if you see that wording, that's a good thing. That means you don't have to do a limiting problem. It means the one I gave you is the limiting, which is the one that determines everything else, including how much product you can make. So we want to know the percent yield of, it's always going to be a product. So this is where the first thing we have to do is calculate the theoretical yield. And this is always a stoichiometry problem. So if you guys want practice, you could pause the video. I'll just get you started. You're going to start with grams of carbon monoxide, and then you're going to convert that into grams of this methanol. So I'll let you guys pause and then try that, and then I will have you come back. So based on stoichiometry, with the beginning amount of carbon monoxide, we should get 85.8 grams of the methanol. So I did my stoichiometry problem. This is theoretically how much we should get, but will we get that much? The question is saying that we really did get an actual yield of 68.4 grams. So if they say produce, that means this is how much was actually made. So to calculate my percent yield, then it's going to be equal to the actual yield, what I really get in the lab, over my calculated theoretical yield. And then I multiply by 100 to get a percent. So for this one, I get 79.7% yield. Okay, one more problem. This one is a limiting problem too, because I'm telling you that we have 2.5 moles of hydrogen and 3.5 moles of oxygen. So I haven't said that I have an excess of one of them. So that means I need to figure out which one's the limiting, because that will be the one that determines how much product I can make. So the good thing is they're both in moles, because that's our first step, would be to have them both converted to mole, but they are. The second step is I'm just going to take one of them and convert to the other, and it doesn't matter which one. I'm going to do the hydrogen and convert it to the other reactant, the oxygen. So my ratio is 1 mole of oxygen for every 2 moles of hydrogen. So when I do that, I get 1.3 moles of oxygen. That's how much would be needed to react with all of 2.5 moles of the hydrogen. So I ask myself, do I have this much? My answer is, yep, I do. If my answer is yes, then that means this is not the one I'm going to run out of. I'm going to run out of the other one. So my LR is hydrogen. So now that I know my LR, I can figure out how much product, because the limiting reactant is the one that determines how much you really can make. So I would start with my limiting reactant, and I'm going to convert it into product. So I'm going to do a mole ratio, and it's going to be 2 to 2. So 2 moles of water over 2 moles of hydrogen. So you can see that those moles cancel. And then I'm going to do molar mass, 18.02 grams of water in 1 mole of water. So once I do that, I get 45 with 2 sig figs, 45 grams of water. So that's, that would be theoretically, like if I start with 2.5 moles, in theory, I should get 45 grams of water. But here in this part, letter C, what if 42 grams are really what we got in the lab when we measured? Then what would the percent yield be? So remember, percent yield is what we really get actually in the lab over the theoretical, which is the stoich, and then times 100. So it's going to be 42 grams over 45 times 100, which is going to be a yield of, just wait, I haven't done this yet. So let's do it together. 42. So it's 93% yield.